Welcome back guys. Today I'm gonna work on a new sensor that is BMA250. Now to have a greater impact and a greater look over this sensor, let's have a watch over the website that is called controleverything.com, and here we have to search for this particular sensor that you can see on my screen. Now let's see what we got for this sensor, and let's say that we have BMA250, which is a accelerator. It's a digital triaxial plus minus 2G to plus minus 16G acceleration sensor, and as you can say, with intelligent on-chip motion triggered interrupt controller. So as you can see, more features are lined up on this website. As you can see, also you can purchase the sensor from this very site. Well, for this video tutorial, I'm gonna interface the sensor BMA250 with a Raspberry Pi, and for that I require a Java code. So let's have a look over the resource tab, and here comes the Java code sample, which we will be exploring in later on this video. So you can download the code as the file from here, and you can also have the code from github.com, and the repository there is control everything community. Now what we require and we will do is to make some connections along with the sensor and other hardware. So let's have a look over that also. The hardware connections for the sensor we are going to make is this. That's BMA250 digital triaxial accelerometer. Now here is our Raspberry Pi, as you can see on my screen, and these are the GPIO pins of the Raspberry Pi. Now what we need is an I2C shield, which you can see, and it's available on the website controleverything.com. Now why do we require this I2C shield is to make connections with other I2C devices and rather make them easy. So gently place the I2C shield over the GPIO pins of the Raspberry Pi, and this here, a connecting cable is used to make a connection among the sensor and the I2C shield. Now gently place it with the sensor, and while making this we have to make a recommendation that it says that the ground terminal of the sensor should be connected to the ground wire of the cable, and similarly for the I2C shield also. So we are done with this connection. Now what we require is to power up our Raspberry Pi, and here comes a micro USB cable. Just slightly insert it over the power jack. Now finally we need to make an internet connection. For that we have two ways. First of all, an Ethernet cable is required, which you are able to see on my screen, and gently push over the Ethernet jack. Next, if we don't have the first, we can go for the wireless nano adapter for the Wi-Fi connection, so that we can have the internet connection for that. So as we are done with these connections, what we require to look have our code for what we want to interface the sensor. Now what do we require is our Java code, so that we can interface the sensor with that along with the hardware connections we have just made. So for that, log in to github.com, and here we have to search for the repository in which the code resides, and it says that control everything community. Now log in here, and here search for the sensor that BMA250. Now this is the sensor we are talking about, and this is the code we are looking forward to explore. It's the Java code. But before let's have a look over the instructions we need to follow for Java code. We have to download and install Pi4j library on the Raspberry Pi, and this link pi4j.com will help us to install Pi4j step by step. And as you can see, the requirements and the commands for the installation are here. Please go through it carefully and install this before running the code. Now this is the command to compile the Java code, and this is to the run the code. Note it down carefully. Now get back to the Java code so that we can explain it step by step. So it's a .java file, as you can see. First of all, we have imported some of the libraries as you can see, and created a class named BMA250. Now next we have the address of the sensor, and we have bus.getDevice to get that is 0x18. Now coming the writing section part, which says that we have selected range selection register 0x0f, and we have set the range, which is the command plus minus 2g, and that's 0x03. The writing part is here. Now we have selected the bandwidth register that goes for 0x10 address, and we have sent the command for bandwidth equal to 7.81, that is 0x08. So after we have sent the command, the sensor will respond, and to get the response we have to read the data back. So we are reading the data 6 bytes of data from address 0x02 in the form of x, y and z axis data. As you can see, this is the command there. Now as we get this data, we have to convert it to feasible part, which is according to the data sheet, and it's 10 bits. So this is the data for x, y and z axis. At the very end of our code, we have the output data to be displayed on the screen, which is in the form of acceleration in x, y and z axis. It's perfectly formatted and it's a very generalized code in the language Java for the sensor BMA250. Now what we require is to show the working of this code. So be it. Now what do we require is to show the working of this Java code. So for that, copy this entire Java code and open up the terminal. For Raspberry Pi we have just connected through internet, and here create a new file, BMA250.java as the extension says, and here we have to save the file, paste it and save the file. Now this is the command to compile, as you can notice, and wrong command. Now this is the command, as you can see. Now here we go for the compilation and it's good. Now this is the command to run the code. Now we can have the data for the acceleration in x, y and z axis. As you can notice, it's almost stable as the sensor is being in the rest position. Now when I try to rotate it and send the command, the data for the acceleration in x, y and z axis will change dramatically. As you can see, all the values are being displayed as the rotation of the sensor is in motion. So this is how the acceleration in x, y and z axis works in the form of Java for the sensor BMA250. Now let's have a look over the features, the applications for this sensor, and let's proceed. The BMA250 is a triaxial low G acceleration sensor with digital output for consumer market applications. It allows measurement of acceleration in 3 perpendicular axes. An evaluation circuitry ASIC converts the output of a micromechanical acceleration sensing structure MEMS that works according to differential capacitance principle. Now the BMA250 senses tilt, motion and shock vibration. So the typical examples are display profile switching, menu scrolling tap, double tap sensing, gaming, pedometer, free fall detection, e-compass, tilt compensation and a lot more. Now this sensor is available on the website controleverything.com, and the relevant code is available on the resource tab and you can download it from there. Now you can also have the code from GitHub repository, and the repository is Control Everything Community. Now if you have any doubt in the end, any queries, you can contact on the controleverything.com and you can post your comments on the community page of this website. Now for relevant blogs and articles which are according to this sensor, you can got your comments on instructables.com, and if you want to subscribe more video tutorials like this, you can go to your YouTube channel. So in the very end, I hope you enjoyed this video and yourself have a good one, and thanks a lot for the watching.